All right, we're going to go over some examples and some notes on adding and subtracting with positives and negatives. And I'm going to start with the same model that we used in class, with good people on the left and bad people on the left. Good people are signified by a plus. Bad people are signified by a minus. Same thing with on top. Good things are signified by a plus, and bad things are signified by a minus. So when good things happen to good people, that's a positive outcome. So whenever you see adding two positive numbers, that means that you're going to have a positive outcome. If you add a positive number with a negative number, that means you are going to subtract. And then when you match a positive with a negative on this side, you are also going to subtract. When you have two negatives like these, so minus a negative number, like bad things happening to bad people, you are going to get a positive outcome. So minus negative equals plus. Knowing this is going to help a lot when you are adding and subtracting negatives. There are different strategies we can use, so I'm going to go over adding positives and negatives with a number line strategy. So when I have a number line, especially when it's blank, I try to look at the numbers that I'm dealing with to establish where my zero is. A lot of times we can make our own number lines, or sometimes they're given to us on a quiz. But if we don't have it, it's always good to establish where your zero should be. If I have a positive 3 and a negative 7, I'm going to put my zero right smack dab in the middle. And then I'm going to count up, and then I start with this number here. I'm going to start with my positive number. I'm going to go at 3, and so I'm right here. And here's my 3. And if I'm adding a negative 7, remember, that means I'm going to subtract. So it kind of makes sense because you're adding a negative value to something. If you give negative value to something, chances are the value is going to go down. So when I go down by 7, I'm going to go 1, 2, 3, 4, 5, 6, 7, and there's my little dot, and I end up at negative 1, negative 2, negative 3, negative 4. So my answer is going to be negative 4. So when I have negative 8 plus 15, again, you're on the negative and then you're adding 15 to that. So that's kind of a meaty number. We're going to put our 0 right in the middle again. So here's my 0, and now I need to find my negative 8 first. So I would go back 1, 2, 3, 4, 5, 6, 7, 8, and here's my negative 8. Alright, so now I'm going to take this and count up 15. 1, 2, 3, 4, 5. May not be hitting them all the time. 6, 7, 8. Please count the 0 when you're going past it. 9, 10, 11, 12, 13, 14, 15. And if I count from the 0, I'm at 1, 2, 3, 4, 5, 6, 7. Alright, so your answer will be 7 for this example. We also used a positive and negative chip strategy, something that is useful for you visual learners out there. It's good to know that blacks are always positive and your reds are always going to be negative. So if I use negative 3 plus 5, I know I'm going to take my pointer and I'm going to take 3 chips because I've got a negative value and that's red. And I'm going to use 5 black chips. 2, 3, and there's my -3 plus 5 in a visual model. I could do one of two things. I could cross out any black chips that aren't used, or I can connect the red to the black. I like the connecting so that you can see exactly how the numbers match up and they're related to each other. So I am connecting 3 reds to 3 blacks. I have 2 that are left unconnected, so that means I have a positive value of 2. Same thing with 8 plus -10. I'm going to take my 8 black positive chips. Might take a little bit longer for me to drag them down. And then my 10 negative chips here. And when you're using this on paper, a good way to do this would be to draw circles and just put a plus or a minus inside of that. I've seen a lot of students' works that looks like that, and it makes a sense. It gets the point across, and it's a simple way to count them. You don't have to go as far as to create a black and a red chip, but when we have a program like this, it's a little bit easier to do. Alright, and so I'm going to connect my black to my red to see if I have any leftover negatives or positives. And whatever leftover I have is the value on that side. Alright, I'm going to connect to this guy. This guy connects to that guy. Connects here. He connects here. And it looks like I have 1, 2 red chips. So I have a value of -2 because my negative chips outnumbered my positive chips. So I know that on a number line I went beyond the 0 to the left of the 0 to -2. Subtracting positives and negatives using a number line, pretty much the same concept, but we just have to be very conscious of where we're going. I have 12 minus -7. I'm going to look right back here. I have a minus negative. That means I know I'm going to add. So this turns into 12 plus 7. So I'm going to count up from here. I'm going to establish my 0 right here, because if I'm at 12 plus 7, I know that I'm not going to go past the 0 on the number line. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And there's my 12. And again, you're going to go a little bit further. You're going to jump up 7 from there. 3, 4, 5, 6, 7. And right here, I end up with 19. So now I'm at -4 minus 6. And this gets a little bit tricky too, because we're starting at a negative number and we're taking away from that negative number. So the negative value is actually going to increase. I know that it's going to increase. My numbers are going to remain in the negative, so I'm just going to place my 0 right over here. And I'm going to start 4 back from 0 because I know I'm at -4. Get my plot pointed here. I'm going to go 6 back from -4. And if I go 6 back from -4, and I count 1, 2, 3, 4, 5, and I've got one more to go, 6, I know I am 10 behind 0 now, so my answer is -10. We're just going to go into straight computation here, because a lot of you guys have good number sense, or this kind of stuff just makes sense to you. So we have 3 minus negative 5. We look at our little model here, 2 negatives equals a plus. So we go back and we can call this the same as 3 plus 5. And we get an answer of 8. So now we have 6 plus negative 8. And you know when you add a negative value, you're going to be subtracting. So that could turn into 6 minus 8. All right, now right here, since 8 is a bigger number than 6, I know my answer is going to be negative. I can use a number line if I want to. I can count backwards to arrive at the answer, or I can just keep it in the back of my mind that my answer is going to be negative and do a simpler problem. I would have negative 8. If I reverse these, I could also call it negative 8 plus 6. But if I take this away and I make it 8 minus 6, I arrive at 2. I gave myself the basic operation here to find out that I'm arriving at 2. But I've already determined that I have a negative value, so I'm going to keep that negative there. My answer is negative 2. Okay, and now I'm going to use negative 7 minus 6. And again, I'm taking 6 away from negative 7. So I know that negative 7 is going to be even more negative because I'm subtracting 6 from that. So theoretically, you're going to have a larger number than 7 or 6, but it's going to have a negative value attached to that, so that we're going to have to consider that as well. So I'm going to put my negative value here, and if, again, I'm not good with adding and subtracting negatives, and I have a number line in my head, or counting backwards, I could just take these negatives and make it 7 plus 6. An easier problem for me to work with. And I have 13. Since I've already determined that this is going to have a negative value to it, what I'm doing is using the inverse. Inverse means opposite. So negative 7 minus 6 is going to be negative 13. And then the same with 4 plus negative 9. That's really going to turn into 4 minus 9. And again, you know you're going to have a negative value here. And 4 minus 9 is the same as negative 9 plus 4. So I know that the way the number looks on the opposite side of the number line, if I have negative 9 plus 4, I'm going to theoretically have an absolute value of less than 9. So I can go ahead and think to myself, all right, well, what's 9 minus 4? I'm using that inverse model again. 9 minus 4 equals 5. Well, all the while, I've already determined that this has a negative value, and so I take 9 minus 4 equals 5, and I give myself an answer of negative 5. So those are some different strategies that you could take when you're adding and subtracting positive and negative numbers. I think having this part in the back of your mind is always going to help you. If you're a visual learner, our chip model is going to be good. or our number line model will be good too. This kind of touches base on what an inverse is. We didn't talk about this too much in class, but if you look at it like this, that is another way to be able to solve for negatives, and then knowing that it's going to be the opposite of what you have.